So today in this video, we're going to be talking about the mechanisms and causes of Alzheimer's disease. So a little overview, if you remember from last time, Alzheimer's disease is damaging of the brain, right? And it's not just damaging of the brain, but the neurons in it. And even more specifically, not just the neurons themselves, but their ability to communicate to other neurons, because that's how our brain works, right? That's how we remember things, that's how we function in our day to day lives. If you want to remember something, the neurons fire and you retrieve that memory through those neurons connecting. So, Alzheimer's disease is when you have this disconnect between neurons, and then those neurons die because they cannot communicate anymore. So we'll be talking about the brain, genes, and environment and lifestyle. So the brain is in those mechanisms are the how. How is this happening in the brain? What is making people lose their memories of their loved ones? And then why? Why is that happening? So we have this mechanism, but how does that come about? Why does it happen for some people but not other people? So, starting with our how, neuron connection is really, or it should be communication, is really the main focus of this. And the thing causing the lack of neuron connection are the plaques and tangles. Now, we'll be going through the plaques first. The plaques are this buildup of beta amyloid protein. So, beta amyloid protein, there's like a byproduct of this, right? And all these proteins start building up, right? And that causes a disconnect between one neuron and the next. They cannot communicate anymore if you have this buildup of this protein. And it builds up between neurons. So going from one to another, when it's all floating around, it's built up between them. We have a picture right here. So we have the neurons that are purple, and then we have the plaques that are affecting the connection between those neurons. All right, and tangles. Tangles are made up of a protein called tau, the tau protein, and this buildup happens actually inside the neuron and affects the neuron's ability to communicate with another neuron from the inside. So we have this example again. We have the normal one and the Alzheimer's one. If you see inside the neuron, you see all of the tangles right there made up of the tau protein. And you do not see that in the normal one. Okay, and you might think, well, that's just a few neurons. How big of a problem can that be? Well, if you're looking at the brain structure, after a while, it does become a huge problem. So if you're looking here, if you look at the grooves of the brain, the sulci, they get very big because there's lack of that neuron connection. Neurons start dying from a shrinkage of the brain. You also see the gyri. They also get very small. See, we have the same spot, but a huge shrinkage going on. That's what happens. The sulci get bigger for the Alzheimer's disease, and the gyri get smaller. So, why? Why does this happen? It's mechanisms of neurons not connecting as well. Why? Well, one answer is genetics. Now, there is late onset Alzheimer's and there's also early onset Alzheimer's. Alzheimer's, not timers. Anyway, different genes affect the late onset and the early onset Alzheimer's. So, starting with the late onset Alzheimer's, this is the more common Alzheimer's. It is 90 to 95% of Alzheimer's have this specific one. And it's a combination of genes and environment. So, not just genes, but genes do play a role. The main gene contributing to this is the E4 apolipoprotein. So, the allele is the E4, and the apolipoprotein is the gene. Now, what this does is that it decreases your ability to break down these beta amyloid proteins. Now, if you have one allele, you're not as much of a risk as if you have 2 alleles. If you got one from your mom and one from your dad, you would be more at risk. But even then, this isn't, um, black and white situation. People who have these alleles still don't get Alzheimer's. So, oh, and here are these, um, amyloid plaques that would be hard to break down. So, now moving on to early onset. Now, early onset is a lot more rare. It affects 10 to 5% of people who have Alzheimer's, so it's definitely more rare, and it is affected by different genes. Also, it's more affected than from genes than environment. Now, it's a lot more rare than the late onset Alzheimer's. It's about 5 to 10% of people who have Alzheimer's have early onset. Now, this is definitely more focused on genes than the last one. Genes are a huge factor in this. This is the genes that people test for when they have Alzheimer's. Now it's the PSEN1 and PSEN2 genes that they'd be looking for that affect um, early onset. Now, early onset, what it does is it affects how these beta amyloid proteins are being broken off, right? If they're being broken off very small, then it's not going to have much effect. But having these genes will make the breakage of the proteins very big. And the bigger the breakage of the proteins, the more likely it is to build up and not be able to be broken down by the body. And again, those are the beta amyloid proteins that you would be building up. Right. There's also another form of the mechanism behind early onset. It's trisomy 21, aka Down syndrome. Now, as a lot of you know, they have an extra chromosome 21. And chromosome 21 deals with the ability to produce APP, and APP affects the production of the beta amyloid proteins. So that's also an underlying mechanism. So it's not just genes, there's also other reasons. The functions of the brain, right? So we have glucose production. So how well is our body being able to send energy to our brain, to the parts that it needs to? How well functioning is our body? Same thing with oxygen. How much circulation is going on? Is the brain and the neurons getting the oxygen that it needs? Are we functioning to that point where we can break down those beta amyloid proteins? And also, inflammation will affect the ability to break down those proteins. So, everything I just talked about in the last slide was the functioning of the brain. So, how do we get that functioning better? How do we get the glucose functioning better, the oxygen, the inflammation? How do we get the brain functioning better? Well, I'll first tell you that there is a huge connection between vascular diseases such as heart disease, high blood pressure, stroke, and Alzheimer's. So there's a connection between health and Alzheimer's. There's also a connection between metabolic diseases and conditions such as um, diabetes and obesity as well. And what you can see from these is that these conditions are, a lot of them in many cases are preventable with good diet, exercise, and sleep. So, if you're wanting to know how to help keep up your cognitive function and the function of your brain that may be important for Alzheimer's disease, then diet, exercise, and keeping yourself healthy is definitely a contributor to that. All right, so we're coming to the end of our video. A quick summary. So we talked about the definition of Alzheimer's and what that means, the neural connections, right? We talked about the neural mechanisms behind that. Why is this happening? What is causing this lack of connection between neurons? And then potential causes such as genes and environment and lifestyle. So, a little take home message, just ask yourself, would you ever test yourself for Alzheimer's disease? Would you want to know this? Some people say, no, I don't want to know it. Um, I just want to live my life, not having to worry about that stress of forgetting all my loved ones. Some people want to know, some people want to do everything they can to slow it down or learn as much as they want to about the disease. So there's also a link under this video that will give you more information about the mechanisms and how they work of Alzheimer's if you're curious. So, and with that, that is the end of our video. I hope you have a good one and stay tuned for the next video. We're going to be talking about the treatments of Alzheimer's disease. So.